Today's topic is Kirchhoff's law. It has two parts. The first one is called the Kirchhoff's current law or the KCL. It is basically one of the fundamental laws used for the circuit analysis. KCL is the first law and it deals with the conservation of charges. So KCL is basically the conservation of charges. It states that if we want to write the statement, it states that the total current entering a junction or a node is exactly equal to the current leaving the node. So Kirchhoff's current law states that the total current entering a junction or a node of a circuit is exactly equal to the current leaving the node. In other words, we can say that the algebraic summation of all currents entering and leaving a node must be equal to 0. So in other words, in mathematical format, we can write the sum of all currents at a junction at a particular time is equal to 0. Here the n is the total number of branches with the current flowing towards or away from the node. Note that here the term algebraic summation means we have to take into the account of the direction and the sign of the currents. Usually the current entering a node is taken as positive and the current leaving the node is taken as a negative. So if we want to write the statement in the other format, we can write the algebraic summation of all currents, that means the entering as well as leaving the junction, should be equal to 0. Now let's have some elaboration of the topic. Let's say this is the junction of a circuit, and in this junction different currents are flowing in different branches. This is I1, it is I2, I3, I4 and I5. So in this case, we basically consider the current which is entering the junction as positive. So in this case, the current entering the junctions are I1, I3 and I5. These are the currents, total currents that is entering the junction. And the current leaving the junctions are I2 and I4. So according to the KCL, I1 plus I3 plus I5 should be equal to I2 plus I4. In other words, we can write it as I1 plus I3 plus I5 minus I2 minus I4 equal to 0. That means the current which is entering the junctions is taken as positive, like I1, I3 and I5, and the currents leaving the junction is taken as negative, like I2 and I4. If we take a small example, consider a circuit with a voltage source of 24 volt. The resistance here is 8 ohms, let's say R1, and the resistance R2 is, let's say, 12 ohms. The current which is passing through the R1 resistance is taken as I1, and the current in R2 resistance is taken as I2. And the total current from the source is considered as I. Now, as we see, these two resistances are connected in parallel with the voltage source, that is 24 volt. So the potential difference across each resistance will be same, that is 24 volt. So using Ohm's law, we can find the current in R1 resistance. So that will be I1 equal to 24 upon 8, that is 3 ampere. And similarly, the current in R2 resistance, I2, will be equal to 24 upon 12, it is 2 ampere. Now, if I want to calculate the total current from the source, that is I, so here we can apply the KCL. Let's say this junction is A. So as per the definition of the KCL, I is the incoming current, I1 is the outgoing current, and also I2 is the outgoing current. So the total incoming current should be equal to the sum of total outgoing current. So I will be equal to I1 plus I2. Now the value of I1 is 3 and the I2 is 2. Therefore, the total current from the source is equal to 5 ampere. In this way, we can apply the KCL to analyze any circuits to find the relations between the currents in different branches which are connected at a particular junction.